Lesson 14.1 is finding limits using tables and graphs. So first, what is a limit? This is notation for a limit. This says the limit as x approaches c of the function f of x is equal to n. And what that means is as x gets infinitely closer to whatever this number is c from both sides, then your function is going to get infinitely close to whatever this y-coordinate is, n. So the first thing we're going to look at is finding limits using tables. So we want to find the limit as x approaches 3 of 5x squared. So I set up this table with x values starting at 2.98 and going up by 1/100th, so that 3 is in the middle. This way we can see values below 3 and values above 3. Because when we're looking at a limit, it has to approach the same number from both sides for that limit to exist. So go ahead and pause the video and use your calculator to fill out the rest of this table. So here we have the rest of the table, and as you can see, as you approach 3 from smaller numbers, you're getting closer and closer and closer to 45. As you approach 3 from bigger numbers, you're also decreasing to approach 45. So from both sides, you're getting really, really infinitely close to 45. In this case, you actually do equal 45. So the limit as x approaches 3 of 5x squared is 45. So now for the next one, we're going to have to use our calculator to be able to do this. So you can enter sine of x over x into y equals in your graphing calculator and create a table out of that. So we want to find the limit as x approaches 0 of sine of x over x. If you actually plug in 0, you'd get a domain error. You can't plug in 0 into this function because you have an x in the denominator. That's why when you look at the table, x equals 0, y is an error. But we can look at the limit just cares about what's happening around the x-coordinate, not necessarily the x-coordinate itself. So as we look at this, if you were to scroll your cursor over, you could actually see the exact numbers here. It just rounds it for the table. But as you get closer to 0 from the smaller or the negative numbers, you're getting closer and closer to 1. And then as you approach 0 from the bigger numbers, you're also getting closer and closer to 1. So even though at x equals 0, there is no y-coordinate, it doesn't exist, the limit as x approaches 0 of sine of x over x is equal to 1. This is one that you'll need to have memorized for this class. So the next part is finding limits using graphs. So we have this function f of x equals x squared minus 1 over x minus 1, and we want to find the limit as x approaches 1 of f of x. So is 1 in the domain? Can I plug 1 into this function and get a y-coordinate? Because of this x minus 1 in the denominator, you can't plug in 1, it's not in the domain. But we can graph this function to figure out what it looks like and still possibly find a limit. So first thing is go ahead and factor the numerator. So pause the video and factor the numerator. So if you factor the numerator, you get x plus 1 times x minus 1 all over x minus 1. So that means because this factor exists both in the numerator and the denominator, you have a hole here. So at x equals 1, you have a hole. And the way we find the y-coordinate of the hole is now you actually plug in 1 to this simplified form, and you get 2. So at 1, 2, there's a hole. The rest of the graph looks like the line x plus 1. So this is what the graph x squared minus 1 over x minus 1 looks like. It looks just like the line x plus 1. There's just a hole at 1, 2. So now as we're looking at the graph, we want to find what the limit as x approaches 1 of the function is. So we want to look at as the x-coordinates approach 1 from either side, what are the y-coordinates approaching? So as you approach 1 from the left, what are your y-coordinates getting really infinitely close to? They're getting really infinitely close to 2. As you approach 1 from the right, what are your y-coordinates getting close to? They're getting really infinitely close to 2. So even though you never actually get a y-coordinate of 2, the limit, what the y-coordinates are infinitely approaching, is 2. So the limit as x approaches 1 of f of x is equal to 2. It's just the hole that we got from this up here. So now here we have a piecewise function. Go ahead and pause the video and graph this piecewise function. So here you have this piecewise function. The line 3x minus 2 for everything except for x equals 2. So at x equals 2, which is y equals 4, you're going to pull that out and create a hole. and then you just have the line 3x minus 2. And then at x equals 2, they're saying it's the y coordinate of 3, so it's this blue point here. So if I asked you, what is f of 2, your answer would be 3. But that doesn't necessarily mean that the limit as x approaches 2 is also going to be 3. We still need to look at what the y coordinate's approaching. So as we approach 2 from the left, what are your y coordinates approaching? They're getting really, really close to 4. As you approach 2 from the right, what are your y coordinates approaching? They're getting really, really close to 4. So even though f of 2 is equal to 3, the limit as x approaches 2 of the function is actually 4. So those aren't always going to be the same value. So now we have f of x is equal to 1 over x. Go ahead and pause the video and graph this, and then see if you can figure out what the limit as x approaches 0 of f of x is going to be. So here we have f of x equals 1 over x. We have asymptotes at both the axes. If I asked you what f of 0 was, that does not exist. It's not in the domain, but it could possibly still have a limit, as we've seen before. So as we look at x is approaching 0 from the left, where are your y's going? Your y's are going down towards negative infinity. As you approach 0 from the right, where are your y's going? Your y's are going up towards positive infinity. So are those the same numbers? Are they going to the same place? They're not going to the same place, so your limit does not exist. So if your y values from either side don't approach the same value, we say the limit does not exist. So try this one. We have f of x is equal to 1 over x squared. Find the limit as x approaches 0 of the function from this graph. So go ahead and pause the video, graph it, and find the limit. So if you graph it, you have asymptotes at both the axes, but on this one, both are above the x-axis because it's an x squared. All your y's are positive. So it looks like this blue graph here. So then as we approach 0 from the left, your graph is going up towards positive infinity. As you approach 0 from the right, your graph is going up towards positive infinity. So this one's a little bit of a trick question. There's two answers. You will see that the limit as x approaches 0 is equal to positive infinity. You'll also sometimes see does not exist. The reason there's two is because technically a limit has to be a real number, and positive infinity is not a real number. So that's why sometimes you'll see does not exist. However, the AP Calculus exam accepts positive infinity, and it's more descriptive. So usually we like to see the positive infinity. But just so you know, you might see this does not exist sometimes because positive infinity is not a real number. So remember, when you're doing a limit, whether from a table or a graph, whatever the y value is approaching, it has to be the same from both sides for the limit to exist. So as you approach x from either side, smaller or bigger, your y value has to be approaching the same number. It might not be the same as the actual y coordinate at that, as the one we saw with the piecewise function.